Hello, my name is Marq from AGHAMALAYAN. In this lesson, we are going to discuss about projectile motion. But before we get into this lesson, it would be advantageous or helpful if you have knowledge regarding linear kinematics. If you want to touch up your knowledge regarding linear kinematics, well, you can check out our video that's all about that, linear kinematics. Before we discuss what projectile motion is all about, let's define a few terms. A projectile is the object that is being launched, and given that a projectile has an initial velocity, it travels a parabolic path known as its trajectory. Basically, projectile motion is the combination of both horizontal motion and vertical motion. Remember that in these certain types of problems, air resistance is usually neglected. Also, acceleration due to gravity is experienced by the projectile. This acceleration acts vertically downwards. When we analyze projectile motion problems or situations, it is essential to remember that both the vertical and horizontal motion are independent from one another. Basically, what that line means that both the vertical and horizontal motion are independent from one another is that they don't affect each other. The vertical motion doesn't affect the horizontal motion, and the horizontal motion does not affect the vertical motion in any possible way. Aside from that, projectile motion has another principle. Let's say we are on a building about, let's say, X meters tall. We drop an object straight down and we drop the same object at an angle. So it makes this shape. Since vertical and horizontal motion are independent from one another, the time it takes to reach the ground from both objects, one at an angle and one straight down, is the same. Since, again, vertical and horizontal motion are independent from one another. Always remember to separate the horizontal and vertical components. Given an initial velocity v0, separate the components. So the v0, when you draw it in, let's say, a right triangle, the v0 serves as the hypotenuse, then the v0x and the v0y serves as the legs of the triangle. So to get v0, you just apply the principle of the Pythagorean theorem. So when you separate the two components, the horizontal component and the vertical component, you get these two formulas. So for the horizontal component, you get the v0x, or the horizontal component, would be equal to v0, which is the initial velocity of the entire situation or problem, times cosine theta. Theta being the angle of the launch. So if the angle is flat or at 0 degrees, just insert cosine 0. For vertical component, it's practically the same. So v0y would be equal to v0 times sine theta. So v0x will be the initial horizontal speed or the horizontal component, while v0y will serve as the initial vertical speed or the vertical component. It's just the same thing but with different wordings. Again, v0x is equal to v0 times cos theta, while v0y would be equal to v0 times sine theta. Remember that the horizontal motion has zero acceleration and constant horizontal velocity. So, you will only need to remember two equations for horizontal motion. Vx, v sub x, or the final velocity of x, would always be equal to the initial velocity of x, since there is zero acceleration. And d sub x, or distance traveled horizontally, would be equal to v0x times time. Again, that's why we recommend that you have prior knowledge with regards to linear kinematics, since this is just an application or a combination of both linear kinematics from a horizontal perspective and a vertical perspective. For vertical motion, acceleration is always constant. Acceleration is constant due to the gravity. and that its velocity at the highest peak or at the very top of its trajectory is always zero. You need to remember only a few equations for vertical motion. The first equation is v sub y would be equal to v naught y plus acceleration times time. And the distance traveled at y, or vertical distance, would be equal to v naught y times time plus 1/2 times acceleration times time squared. While the special case, if you're going to solve for the final velocity at y, v naught y squared would be equal to v naught y squared plus 2 times ay times t sub y. So if you're going to look at the equations, you will see that it's just a mirror of your four fundamental equations in your linear kinematics. So if you know how to apply your linear kinematics, this will be easier for you to understand. There are special cases when it comes to projectile motions. These cases usually appear or come up when you're searching or solving for either A, its time of flight, B, the maximum height, and C, the range. There are special equations that can be used to solve these scenarios. Assuming that the height where the projectile was launched initially is the same as where the projectile will land. So you have the same plane in a way. That's the best way I can describe it. You just land in the same level. That's the most important part. If the object or projectile doesn't land on the same plane or height, these equations will be of no use to you. For the time of flight, it's a special case. It's also known as the hang time of the projectile. So the general or simplest definition I can give you for time of flight is that it's the total elapsed time during the flight of the projectile. Again, assuming that the initial launch point of the projectile is the same, lies on the same level as where the projectile will land. So the formula for the time of flight or hang time would be equal to 2 times v naught. So initial velocity, not the initial x velocity, not the initial y velocity, but the initial velocity of the projectile times sine theta over g. That's the formula for time of flight. Yeah. For the maximum height, it's the maximum vertical distance that a projectile reaches. So in short, the very tip of the trajectory, that's your maximum height. And the formula for maximum height is v naught squared times sine squared theta all over 2g. Again, v naught squared times sine squared theta all over 2g. That is your formula for maximum height. For solving the range, by definition, it's the horizontal distance between the launching point and the point where the projectile reaches. Again, horizontal distance. So the final answer must be in meters, hopefully. If you're following a set units, it's probably meters, the unit for range. So the formula for range would be v naught squared times sine 2 theta. Okay, sine 2 theta, remember that, over g. So that's the formula for range. Okay, now that you have the formulas needed and hopefully you understood the concepts regarding projectile motion, let's try to solve some problems involving projectile motion. Let's have this problem. A physics book slides off a horizontal tabletop with a speed of 1.1 meters per second. It strikes the floor in 0.35 seconds. Ignore air resistance. Find A, the height of the tabletop above the floor, and B, the horizontal distance from the edge of the table to the point where the book strikes the floor. For letter A, what we will use is this equation. d sub y would be equal to v naught y times time plus 1/2 times a sub y times t squared. Since we know that the acceleration in the y-axis is also its gravity, and we know the time it takes. Since the initial velocity given is from the horizontal perspective or horizontal axis, we know that it has zero y-axis. Not zero y-axis. Zero velocity at the y-axis. So basically, we will just cross out the v naught y times time, leaving us with a working equation of d sub y would be equal to 1/2 a sub y times t squared. So substituting the values, we will have d sub y would be equal to 1/2 times 9.81 meters per second squared, since we know that acceleration at the y-axis is always due to gravity. Then we just multiply it by the time, which is 0.35 seconds. Inputting that into our calculator, we would have a final answer of 0.60025 meters. Or if you're going to round it off in 4 decimal places, 0.6003. For letter B, we will use the equation for horizontal displacement. Since the question is the horizontal distance from the edge of the table to the point where the book strikes the floor. So the equation that will be used would be d sub x would be equal to v naught x times time. When we substitute the values, we will have d sub x would be equal to 1.10 meters per second, which is again stated in the problem as the horizontal speed, times 0.35 seconds, since it's the only time given in the problem. So when you simplify it, your final answer would be 0.385 meters. Or when you round it off to 2 decimal places, 0.39 meters. Now for the last problem for this video. Yay! Let's read and analyze. A projectile is fired with an initial speed of 36.6 meters per second at an angle of 42.2 degrees above the horizontal on a flat firing range. Determine the A. Maximum height reached by the projectile, B. The total time in the air, and C. Total horizontal distance covered by the projectile, aka its range. For this problem, we will simply use the formulas or equations for the special cases which I showed to you earlier in this video. For letter A, we will use the formula for the maximum height. So h, or maximum height, would be equal to v naught squared times sine squared theta all over 2g. So since everything is given in the problem, we will just substitute the values, and we will have h, or maximum height, will be equal to 36.6 meters per second squared. You square the entire thing, times sine 42.2 degrees squared. Again, the entire thing squared, all over 2 times 9.81 meters per second squared. Inputting that into your calculator, you will have a final answer of 30.8378 meters. For B, we will use the formula for total time or hang time. So time would be equal to 2 times V naught times sine theta all over g. Inputting the values again from our problem, we will have 2 times 36.6 meters per second times sine 42.2 degrees all over 9.81 or 9.81 meters per second squared. Your final answer should be 5.0173 seconds. For letter C, we will use the formula for range. So range would be equal to V naught squared times sine 2 theta all over g, which will be equal to 36.6 meters per second times sine 84.4 theta 4 degrees, I'm sorry. The 84.4 was just 42.2 times 2, given the problem and the data from the problem, all over 9.81 meters per second squared. Simplifying that, you will have a final answer of 136.0374 meters. There may be a lot of formulas to memorize for projectile motion, but here is my technique to at least help you recall the formulas. I just derived the equations for horizontal and vertical motion from the usual equations that we use for linear kinematics. You only need to remember that there is no acceleration for horizontal motion, and for that vertical motion, the formulas will just remain the same. However, acceleration will be due to gravity, that is for the vertical motion. Then for the special cases, the maximum height, the range, the hang time, and those three for the special cases. The maximum height will have the 2 above the sign. That's why there would be a 2 beside g in the denominator. While for the range, there would be a 2 beside the numerator, or beside the numerator. That's why the 2 in the denominator will disappear. And that's pretty much my tips for memorizing the equations. At the end of the day, it's up to you how you memorize it, but that's just my suggestion on how I personally memorize the equations. Again, this is Mark from AGHAMALAYAN, and thank you for watching. I hope you will pass your upcoming exams, and maybe you learned a thing or two from this video. And if you have other problems or questions in the classroom regarding science, specifically physics and chemistry, please do check out our other videos if you're interested. So yeah, once again, thank you for watching, and I hope you learned something new today.